All right, you're going to row reduce a matrix with Cocoa Bananas, the Wonder Ferret. She knows what to do. First of all, we got to knock off that 4. This 4 right here, that 4 has got to go. So we knock off that 4. Now in the process of knocking off that 4, this 1 changes, which is too bad because we'd like a 1 in that spot, but it changes into a 5 or something. So I did a couple of more operations here off to the side, just wrote them down to get this far. You can try them yourself. You should be able to. But the point of this exercise is we're going to get the matrices for these row operations, all these row operations. We're going to have that product of matrices written out for you. And then if you want to try it in a computer algebra system or by hand, which would be pretty outstanding, you're supposed to get the inverse matrix out of that. That's the goal. Each of these row operations can be written as a matrix. You can write the outcome as a product of those row operation matrices. Just multiply them all out. So I'm trying to illustrate the idea that this identity matrix keeps track of all the stuff that you do. It keeps track of all the stuff that you do as you turn the original matrix A into an identity matrix. So if it keeps track of all the stuff you do as you, in a sense, undo matrix A, that's how you get the inverse of matrix A. Anyway, so there's 3 operations to get this far. Then there's 2 more. In this operation, I'm going to use this 1 to knock out that -1. Row 1 plus row 2 replacing row 1. I'm going to use this 1 to knock out that 3. -3 times row 2 plus row 3 replacing row 3. Those can be written as matrices. And it gives me that setup over there. And all that's left is use this -1 to clear this column and make it a +1. So you can see all this stuff. I'm going to add row 3 to row 1 as is. That'll kill off that 1 that's at the very top there. This 1 that's right there. That 1 gets knocked out. Then I turn the -1 at the bottom row 3. I make that a +1. Then I use that +1 to knock out this -1. So that's these 2 moves, and I get the identity matrix here, and this is the inverse matrix of the original matrix A. Now let's see another way to get that result. All right, now here's the other way to see and understand what's going on. The first thing that we did was -4 times row 1 plus row 2 replacing row 2. Here is the matrix that if I have matrix A right here and I multiply by this matrix, it's going to do -4 times row 1 and add it to row 2 and replace row 2, because it's -4 times each element of the first row, one at a time, added to the corresponding element of the second row, and it's going to get written in the second row. So if you don't believe me, try it. But that is this very first row reduction command as a matrix. So you could have matrix A here if you wanted to, but I don't have matrix A here. I just have this matrix by itself. Now acting on it, multiplying from the left is our second move. -2 times row 3 plus row 2, replacing row 2. That's this command. That's how you would write that second command here. And here's -1 times row 2, the third command that we did. Now there'd be 4 more matrices. Their recipes are up here. 1, 2, 3, 4. And then this very last one. Row 3 plus row 2 replacing row 2. That's row 3 plus row 2 replacing row 2. That's this last one. So you can do all these matrices, and if you multiply them all out without anything over here, you'd get A inverse. This, and I'll write for you A inverse here so you can check it yourself. It comes out to be the matrix that we had before. The -7, 2, -3, 16, -4, 7, and then the last row is a 12, -3, 5. And that's the inverse of the original matrix A. These ideas all go together. Try and understand. See you later.